Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 36 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the number of students who participated in sports was 317. It's increasing by 4%. And so we need to find a function that models that. Now, take a look at what we've got here. We actually have a mix. So I want to call out this because we're actually not going to find much help for it in our reference materials. But we should notice that both the answer selection in A and C are both exponential. Okay, so these are both exponential functions because you've got the x up there in the exponent. And then, right, you've got just your b and your d. These are just your basic linear. Because you don't have, it's not a quadratic because you don't have a squared or anything like that, right? Those are just straight lines. So each year the number of students who participate increases by 4%. So this is going to be our clue right here, that we actually are dealing with exponential. Because when we're dealing with a growth rate that is a percent, that is going to be one of our clues that we're dealing with an exponential function. And if we look at our reference materials, we are going to find factoring, we're going to find properties of exponents, linear equations, quadratic equations. We're not going to find anything about exponential functions. So we need to come into the STAAR test with this in mind. So what is our standard form? Well, the standard form of an exponential function is going to be this y equals a times b to the x power. So let's just highlight these things because we're going to be able to grab them from our problem situation. So this a is going to be our initial amount. So sometimes we'll be dealing with population growth. We might say there were 300 giraffes and then it decreased by 7% each year. So that A would be that 300 representing the initial amount of giraffes. Sometimes we will deal with sales, right? The initial price of an item was $20 and then it decreased 5% each week until it sold, right? That initial amount could also be a principal if you're dealing with investment. And you deposit some money, you deposit $1,000, and it increases, compounds at a compound interest rate of 4% or something like that. So what is the starting amount? That's the A. Now this is going to be your growth rate if it's greater than 1. So it's going to increase if it's greater than 1, but it's also possible to have this as a decay rate because it might be less than 1, right? So if it decreases by 4% each year, it's going to multiply by the initial amount and just get smaller. Now this x, what this is not only is it our independent variable, but this represents typically in these situations some type of time unit, right? So in these real world situations, it's going to be the number of weeks, number of years, number of months, number of days, however often that percentage increases or decreases. So let's see if we can match that to what we're doing right here. So this year, the number of students who participated in sports was 317. Look at that right there. That's your A, right? So y equals, and since we're doing f of x, let's go ahead and make it f of x equals, that 317 is going to be your A because that's your initial amount. Now, we need the growth rate, right? It increases by 4%. Now, we're not just going to write 4%. 4% turns into a decimal, right? That's going to be 0.04. But if we do that, that's going to be decay. That's going to make it smaller. So we actually need to add 1 to that in order to keep it as a growth rate. That this 1 is going to keep this initial 317. That 0.04 is going to increase it every time we do the exponent, so it's going to be 1.04 because that 1 is going to capture that initial 317, and then it's x years. So they got that x years right there. So there's our answer, C.